Question 21. We've got three coordinates that make up the vertices of a right angled triangle, A, B, C. So it tells us that angle ABC is the right angle, so the angle at B is the right angle. So imagine we've got our right angled triangle, A, B, C, where B is the right angle. I'm then going to label the coordinates at each point. It's not tremendously important whether they are correctly drawn out on a grid, but if you feel more comfortable, you can always plot them onto a little grid to help you. The difficult bit is that our last coordinate is 4 and then k. And we need to work out what k is at some point. So we need to find out what the equation of the line is that goes through A and C. So this is the one that we're interested in ultimately, the equation of that line. But to find that out, we're going to need to know what k is. And we can use our right angle to help us. Because this line, which we can work out the gradient of, is perpendicular to this line, which we can't at the moment. So let's work out the gradient of our first line. Remember that gradient is the change in y over the change in x. So if we look at our two coordinates, remember y is the second coordinate, it's going to be easier for me to take this one away from that one. So I'm going to do 5, take away 1, change in y, over 6, take away minus 2, which is my change in x. So if I work that out, 5 take away 1 is 4, and 6 take away minus 2, remember that's going to be a plus, is 8, and 4 over 8 is a half. Now, that's the gradient of this line, but we want the gradient of that line, and they're perpendicular, and that means that the gradients will multiply to make minus 1. Or, if you think about it as a half, we can flip it and make it negative. Okay, so gradient 1, so the gradient from A to B is going to be half. So our gradient from B to C is going to be minus 2 over 1 or minus 2. And of course those will multiply to make negative 1. Yeah, 2 minus 2 times minus 0.5, so minus 2 times 0.5 is going to make negative 1. Now that we've got that gradient, we can use it to work out k, because if I take the change in y over the change in x, then my change in y, which is going to be 5 take away k, over my change in x, which is going to be 6 take away 4. So that's going to be 5 take away k over 2, and that equals minus 2. So now I can look at that and go, okay, if I multiplied both sides by 2, I get 5 take away k equals minus 4. And then if I take away my 5 from here, I get minus k equals minus 9. So that must mean that k is equal to 9. So I put that back into my coordinate over here. So I've got 4, 9. So now I want to work out the equation of the line going from A to C. So to start off with, I'm going to find the gradient from A to C. So again, change in y, so A to C, the change in y, dy over dx, delta y over delta x to be accurate, is going to be 9 take away 1, and my change in x is going to be 4 take away minus 2. So 9 take away 1 is 8, 4 take away minus 2 is going to be 6. We can simplify that to 4 over 3. So our gradient from A to c is going to be 4/3. Let's put it into the equation of a formula. So we've got y equals mx plus c. So y equals 4/3 of x plus c. So we put in one of our two coordinates. Well, 4, 9 looks easier to put in, so I'm going to put that one in. So 9 equals 4/3 of 4 plus c. Let's work out what that's going to be. So I've got 9 equals, and then 4 times 4 is 16, so 16 over 3 plus c. If I times everything by 3, that might help me. So I've got 27 equals 16 plus 3c. So take away the 16 from both leaves me with 9 equals 3c. So c equals 3. So on my final formula is going to be y equals 4/3 of x plus 3. But it wants it in the form ay plus bx equals c. So I need to rearrange it. First of all, they're all integers, so I'm going to times everything by 3. So that gives me 3y equals 4x plus 9. Then I'm going to shift it around, so I'm going to move my x's to the other side. So I get 3y minus 4x. Remember, because I'm taking it away from both sides, equals 9. And that's my